So the galaxy on the right, this was discovered by Art Hoag, an astronomer in the early 1950s. And what makes it unusual is that there's an orangish central body that looks like what we call an elliptical galaxy that's very, very circular. Looks very spherical. And then surrounding it is a bright blue ring that's also extraordinarily circular. And there's nothing between the two really connecting it. Mm-hmm. And so it's really not clear how a galaxy like this forms. And so Art Hoag was the first one to find an object like this. And since his time, people have found a few other objects like this, and now we call them Hoag-type galaxies, but only a handful. And so we estimate there are maybe 0.1% or less of the observed galaxies that we've seen so far are Hoag-type galaxies. So they're exceedingly rare to find. And so my collaborators and I, we actually found a Hoag-type galaxy, which is the one on the left, which has a catalog number of PGC 1000714.
How do you go about, and the light from this, we should say, has been 359 million light years, so it's old.
Right, it's
obviously.
old, yeah. I mean, the distance is pretty far. So the light we're seeing from it now has left 359 million years ago.
So how do you find something like this?
So what I was doing, so years ago I was a postdoc, and I was working on a project, and I was looking at a galaxy, and surrounding the galaxy was some field of sky, and I noticed off to the side of the galaxy I was looking at, I noticed what I thought was an elliptical galaxy, and I thought, oh, that's interesting. There's one nearby. I wonder if that influenced the galaxy I was working on, and then I looked more closely at it, and I noticed a faint blue ring surrounding it. I'm like, oh, this is unusual. This might be a Hoag object. So then I did some research, like through the literature. I looked online. And it seems like nobody had noticed this before. And the images that we were using were actually very long, they were basically long exposure images, so we were able to see a little more deeply into the sky, so that's why that blue ring actually popped out a little bit. It's really faint, and so because of this deep image, we were actually able to see this ring kind of pop out a little bit notice it.
And here's the ring. So tell me a little bit more about the outer ring and the inner ring. And you're right.
Right.
At image, it is.
Right. So on the galaxy on the left, I mean, it's obvious. You can see the core, the bulge area that looks very circular, and then you can see this blue ring surrounding it. And so obviously it doesn't look as fantastic as Hoag's object, because that Hoag's object image is actually taken by the Hubble Space Telescope. Okay. This image on the left was taken by a ground-based telescope, so it's not nearly as good as the Hubble image. But the image on the right, what this is called a color index map. And what we do is we just look at the difference in colors. And we've added artificial color to it to kind of highlight things. But you can see the blue circle in the center, around the center there, that's that outer ring. But what we were able to do was we subtracted out the bulge light. So we were able to model the bulge light and subtract that out. And what we found was underneath the light of the bulge, was another faint, diffuse red ring. And that's what makes this galaxy unique, is that not only does it have one ring, it actually has two rings, two seemingly circular rings surrounding this bulge.
And there's different ages in the rings, correct? One is older, one is younger?
Right, yeah. So we're not entirely sure, we're not quantitatively sure what the age of the inner ring is. So we're getting more data to try to figure that out. But qualitatively, we know that the inner ring has to be older. And the reason why we know that is because when stars form, you get blue stars and red stars, and the blue stars shine very brightly and burn out very quickly. The red stars don't shine as brightly, and they last much longer. And what we see is the outer ring is mostly blue, so which means these are all blue stars, so this must have formed very early, must have formed very recently. But the secondary inner ring is actually very red, which means all the blue stars have since burned out, and now we're left with the red stars that are left over. So this must be older than the outer ring.
When you look at this, I mean, it's the frustrating part is that you still don't know a lot about it, but I guess the wonderful part is wow.
Yeah, it's exciting. It's exciting because we don't know a lot about it. So it's still a puzzle. So it's an interesting puzzle. So that's what makes it really exciting, is that we still have a lot to try to figure out as to what's going on with this galaxy.